in the Stone Age, when people were asking, what is disease? What do you think they were thinking about disease? Did they know about disease back then? If someone was sick and they were asking like questions, theoretically, but I'm pretty there is a lot of truth in it. Why is she sick? And people might think maybe she's cursed, okay? Or she has sinned, or she's just unfortunate. And people might say, God knows, who knows? They didn't really have a clear understanding about what disease was. And then they might have a solution, bury them, or pray for them. Probably that was kind of the understanding of disease back then, and that's the knowledge they probably shared in the Stone Age. And time sort of moved on, and then there were a lot of evolution in terms of knowledge. And about BC 400, they got a little better understanding about disease. Okay? So when people were wondering, why is she sick? Then probably their answers might have been, she's cursed, again, still they didn't have complete understanding. And she has sinned, these are still sort of the perception that people might have had. And here's the interesting thing, some people smarter who kind of studied the disease and then they came up with this idea. She is infected by something bad, not sure what that might be, but might be. And more advanced sort of understanding of disease might be she has a dysfunctional body. And then a person who was really thinking deeply about disease back then is Hippocrates, and he's credited with being the first person to believe that diseases were caused by naturally and not as a result of superstition and gods or anything else. So that kind of gives you an idea, knowledge advances by understanding more about world phenomena. So now, in about 1800 to 1900 time frame, they had a little better understanding about disease and how. Because they were curious about disease, they studied about it, they made questions, they made inquiries. And someone did study about it and got more facts and evidence to support their claims. So even in that time period, people still thought about maybe she's still sinned. Or she's infected by something bad, but wasn't sure what that bad thing was. But they got to understand a little more. And then she's infected by bacterium, virus, prion, or fungus, or some kind of or organic sort of element that got into the body and caused an infection and so forth. So people knew more about bacteria and virus and other things because they made questions. They were questioning each other. They were making inquiries, and they were sharing those inquiries, and they wanted to know more about it. And that's how knowledge sort of advanced. So about inquiries. Inquiries basically drive knowledge creation and advancement. It helps knowledge to advance. And more knowledge leads to newer, more useful inquiries. So you see the inquiries is the center of this knowledge creation and advancement. So if anybody asks, what is a disease in the year 2015? What do you think people might think? What do you think they might know by then, 2015? Why is she sick? And they're not going to talk about, oh, she sinned or cursed or anything like that, but they will come up with an even better understanding of disease. So someone may say, still, she's infected by bacteria, virus, etc. She's prone to be susceptible to herpes virus because of certain things. They will be more specific about their understanding of disease. And maybe they will know more about genetical structure and DNA and all these things by year 2050. And they might know exactly why someone gets sick easier or easily than others, and then they will know more about it. So knowledge will continue to advance, and advancement in the various things like molecular biology and genome sequencing and all these things will give us more ideas to understand about disease. But if people are not inquiring, if people are not making questions, knowledge will not advance. If you don't care about it, probably, we're not going to have a better understanding about these things and world phenomena, even the year passes by. So what's involved in inquiries? We want to search for truth, obviously, and we want to challenge and advance existing knowledge, and also we want to verify our understanding and see if we have it correctly or not. And we need to collect evidence to prove our claims. And we need to continue the lifelong journey to know and learn and explain better about world phenomena. And that's the sort of the ecology of knowledge advancement. And because of that, that inquiries will contribute to building more knowledge-based society and economy. But what do we do? When we ask children, when you ask the children in schools, they may say, why do leaves fall and how high does a jet propulsion airplane fly? You know, they have some curiosities, they have some questions. And why do people get old and die? You know, they have all these natural questions that they come up with. And I want to learn more about malaria and how it spreads. You know, some students might be curious about malaria. And some students might wonder, how does my phone show Facebook friends? Do you understand how your cell phone show you Facebook friends on your phone? Can you explain how it works? Some people can. And how does my video from one phone get transferred to another phone? You know, that's a very good question, in fact. If our students are wondering about these things, and if they study more about these things, I'm sure they'll figure out. And someone may say, I need to learn how to program Android phone games. You know, some students might be curious about them, and they want to know how to do that. So these are the kind of human inquiries that we value. But what do we do in our schools today? What do we do in our schools? Okay. Teachers give students what to memorize. They will say, niños, niñas, here's a list of things that you have to memorize because they are going to be on the test. And they may give a question like this, which characteristic of a motion could change without changing the velocity of an object? This is an actual question. It's a state standard question. What does that mean? It means that our students have to memorize them and answer them correctly on this type of question. And they have to memorize a lot of these questions. So someone did all the research to come up with this question because it's a state standard. That means it has to be really a high-quality question. But who came up with this question? Those educators, those teachers, they did all the studies, they did all the research to come up with a high-quality question and make sure there's only one answer. Only one answer. If you have multiple answers, that's not a good question. That's very ambiguous. So someone did all that work. And it's kind of cut off here, but you know, they came up with all these questions for exams. You know, that's what a lot of teachers do. That's what a lot of professors and educators do. They come up with high-quality questions. This is not easy. How many of you have made a multiple-choice question in your life? Have you made a multiple-choice question? Was it easy? I mean, you not only have to understand the subject and topic, you have to know the answer. And you have to come up with distractors that can never be answered. So it takes some time to do research, right? You have to verify. There's only one possible answer. So that's the current education model. Teachers come up with questions while students do rote memorization and they do simple recalls. What's the capital city of Mexico? Oh, Mexico City. You know, you just memorize them and they come up with the answers. That's the kind of questions that we're teaching to our students. So we need a pedagogical paradigm shift. That's what I call this, pedagogical paradigm shift. What it means is that we want students to be doing all the real stuff. Real stuff meaning doing research. We want students to dig in the knowledge database. And we want students to be making questions and inquiries and find answers by themselves. And I think that is the true learning process. And we want students to do all the research, and students are doing all the reflection, searching, collecting evidence. They're planning and organizing and presenting their knowledge and sharing their knowledge. They're critiquing each other's knowledge and summarizing, and all possible ways to generate good questions. That's what we want our students to be able to do. So students are doing all the learning. Teachers are doing the facilitating. They are not giving students information to memorize. So this is a different model that we're seeking. So we're taking a very small step. I think it's a very small step that we're taking. That's why we came up with this project called SMILE, Stanford Mobile Inquiry-Based Learning Environment. So SMILE consists of an open source mobile learning application and mobile interaction management system. So there's a learning management system, and there are mobile devices that run SMILE application. That's what we use in our project. So the vision is this. We envision a change in student-teacher interactions such that students are not just the center of their learning, but they are the active agents of their own learning process. That's our vision. So SMILE model. Teachers are content experts and facilitators of learning, and students can freely ask most of the questions and drawing from their own curiosity and personal experiences. If it is not meaningful for individual students, they are not going to be interested in learning. And therefore, we value their own curiosity, individual backgrounds and their experiences and their skills that they bring into the learning environment. We argue that vast affordances of mobile technology can enable a pedagogical paradigm shift. I like mobile technology because of various reasons, and I will share more about that. And we believe that it can really cause a pedagogical paradigm shift for all learning scenarios and settings around the world. And we believe this mobile technology that we see today would be a catalyst for change in our education system. So SMILE process. These are some of the pictures that we have taken from our projects in various places. So they make questions, they share, they solve the questions, they rate the question, they reflect on them, and exchange, make new questions, etc. These Korean medical students are using iPads to create questions in their medical class. See, they're making questions using iPads there. And this is the global version of SMILE application, which runs on iPhone and iPads. That's an ad hoc version of SMILE application that runs on Android devices, and we also have a web-based SMILE application as well. That's an ad hoc version. This global version needs internet access at all times because server is in the cloud. That ad hoc version does not need an internet access. That is for more of areas where there's no internet access anyway. We're talking about very underserved regions. So SMILE enables students to synthesize, solve, reflect, all these things by making multiple choice questions, and then they can rate their questions as well, and then they submit and share their questions with people around the world. In a way, it's like a Wikipedia. People around the world, they describe things in Wikipedia. Here, people are exchanging questions around various topics. So everyone can make questions on anything and everything, and the SMILE model combines the collaboration and competition, and we leverage mobile media, and questions that students come up with are learning objects, discussion topics, and evaluation vector, and I will explain more about that soon. So I have taken these mobile learning projects to various places. This is one of the classrooms in the Bay Area. It's near San Francisco in California. And we asked the students to create questions on anything that they want to ask about. So students are taking pictures of their own textbooks. They're taking pictures of their graphics, charts, images from their textbooks. They're remixing their content. They're coming up with questions, and they are sharing them. So in a way, they are creating their own content. And here, this photo showing a group of students who are creating questions on science topics. And I have taken this to a place like India. You know, this particular place didn't have a reliable electricity. So we had to plug in that little server that we carry. It's a portable server that manages the mobile learning. It plugs into a car battery, and then it creates an instant network in the school. And that's how we were able to use the ad hoc version of SMILE in places like India, where, I mean, not all Indian regions are developed. I mean, they have big, large metropolitan areas with full of internet access and everything, but still, a lot of places in India still do not have reliable electricity and reliable or any internet access. So that's what you have to use, like ad hoc version of SMILE projects. So students are creating questions here again. They're taking pictures of their textbooks. And sometimes they go out and take pictures of a flower and little animals and they create questions. So that's how they come up with questions and they share them among themselves. And they rate them and then they exchange their understanding. So people ask me, so what's the role of the teacher in this case? The role of the teacher is to verify that the answers that they come up with are correct answers. So that's the role. And then the teacher facilitates the whole learning process. This picture is from Misionet province in Argentina. It's a place, this is the place where they made the film Mission, that movie. That's where they made the movie, The Mission. It's a Misionet province. So many of the children, they were speaking Guarani. You know that language? So anyway, in that classroom, I went in with the SMILE mobile learning devices and the applications and the SMILE server and asked the students, come up with a math question. Come up with the most difficult math question so I cannot solve it. So students took it very seriously. So what they are doing, I don't know if you can really see this. Can you turn off that light here? Maybe it will help for them to see. But basically, what they are doing here is that they are creating a math question as a group, and then look at all the numbers that they wrote down on this paper. They're really serious about coming up with a question because they are motivated. They want to come up with a question that I cannot solve. And they are covering themselves with a big bunch of paper so that no one can see it, so that no one can pick on them and then copy their ideas. So they're like scientists. In a way, many of the Argentinian the students wear this uniform. It looks like a scientist's kind of uniform. And they came up with a math question. Very, very, extremely serious. So when they are creating a math question, they not only have to know the answer, but they have to know the distractors as well. So they are checking each and every answer, making sure there's only one possible answer. That's why they wrote down a lot of things on the board. That's what they're doing. So I took the project to Indonesia, rural village school in Indonesia as well. So I asked them the same question, create a question that I cannot solve. At that age, these are, I think, 4th and 5th graders, they are coming up with questions. They are drawing a triangle there. So what they were doing is creating a question related to triangle theorem. And they took picture of their own drawing here, and they are putting questions. The answers, possible answers. So that's what they are doing. So this particular classroom was a multi-age, multi-group, multi-grade level, multi-ability group class. So it's kind of mixed class. That's pretty common in the developing regions, where there's one school, but you have from 3rd grader to all the way to 6th, 7th, 8th graders all together running in one room, and that's pretty common. And what happens in that scenario with the SMILE project is that those students who are less advanced are challenged by the questions created by more advanced students. And the more advanced students get to experience questions that they never thought of, because other students come up with various kinds of questions. Now, there's a very important thing. What if the student's question was incorrect? What happens to the whole learning process here? In this process, that's an opportunity for development, because the teacher can see which student is struggling with what area. Because sometimes they make the question incorrectly. Sometimes students will come up with wrong answers and wrong choices, etc. That's an opportunity for a teacher to respond. So individual questions coming from individual students are all shared, and they become very explicit when they do that, so that teacher can immediately respond to that sort of scenarios and deficiencies that